Sun dimming experiment, risky research or climate solution? The headlines are stark. 2024 saw global temperatures breach the 1.5 degrees Celsius threshold for the first time. As climate change impacts intensify, the world is grappling with how to respond. Beyond cutting emissions, some scientists are exploring radical, controversial ideas. One of the most talked about, solar radiation management, or SRM, sometimes called solar geoengineering, or even sun dimming. Today, we're diving deep into SRM, what it is, why it's being researched, the huge risks involved, and crucially, the United Kingdom's surprising role as a major global funder in this high-stakes field. Is this necessary research for a dangerous future or a dangerous distraction? Let's break it down. What is solar radiation management? So, what exactly is SRM? The core idea is simple. Reflect more sunlight back into space before it warms the planet. It's like trying to slightly increase Earth's overall brightness, or albedo. Scientists estimate increasing the planet's reflectivity by just 1% could offset much of the warming caused by current greenhouse gas levels. Now, it's critical to understand SRM is not carbon dioxide removal. It doesn't tackle the root cause, the greenhouse gases already in the atmosphere. Think of it as treating a symptom, warming, rather than the disease, high CO2. This means major CO2 problems like ocean acidification would continue even if SRM cooled the planet. The two most discussed methods are stratospheric aerosol injection, which involves putting tiny reflective particles high up in the stratosphere, mimicking the cooling effect of large volcanic eruptions, and marine cloud brightening, which aims to make low-level ocean clouds more reflective by spraying sea salt aerosols. Other ideas, like thinning high-altitude cirrus clouds or even space-based mirrors, are also out there, but SAI and MCB get the most attention. If SRM is risky and doesn't solve the underlying problem, why is it gaining traction in research circles? The primary driver is concern that global efforts to cut emissions are simply too slow. Current policies put us on track for potentially catastrophic warming, maybe closer to 3 degrees Celsius this century, far exceeding the Paris Agreement targets. That 1.5-degree threshold breach in 2024 was a major wake-up call. Compared to the decades or centuries needed for emission cuts or carbon removal to significantly cool the planet, models suggest SRM could potentially lower global temperatures within years of deployment. This theoretical speed makes it look attractive for potentially limiting peak warming or hitting climate targets. There's also the terrifying prospect of climate tipping points thresholds triggering abrupt, irreversible changes like ice sheet collapse or rainforest dieback. Some research, particularly in the UK, is motivated by the idea that SRM might be the only tool fast enough to potentially avert such catastrophes if we get dangerously close. The UK's major research push. This brings us to the UK. While the official government policy prioritises net zero through emissions cuts and states no plans for SRM deployment, the UK has become a significant global funder of SRM research through two major programmes. First, there's a £10.5 million 5-year programme from the Natural Environment Research Council running from 2025. This focuses exclusively on computer modelling, simulating the impacts and risks of techniques like SAI and MCB. Crucially, NERC is not funding outdoor experiments. This program also includes funding for a national public dialogue on SRM in 2025 to 2026.
Check one, check two, check.
Second, and more controversially, the new Advanced Research and Invention Agency, or ARIA, has launched a £50 to £56.8 million program called Exploring Climate Cooling. ARIA's goal is to test fundamental feasibility. Can these techniques actually work? Can they be controlled? And what are the side effects? Critically, ARIA is open to funding small-scale, tightly controlled outdoor experiments if deemed necessary to get data that models can't provide, justified by the urgency around tipping points. They've outlined strict governance rules for any potential experiments, likely learning lessons from the cancelled UK SPICE experiment over a decade ago, which faced governance hurdles. Leading UK universities like Cambridge, Exeter, Imperial, Bristol and Birmingham are involved in the NERC modelling projects, looking at everything from SAI risks, MCB's potential effects on the Amazon, using volcanoes as natural analogues, and even novel techniques. Specific ARIA projects haven't been announced yet. Okay, so the UK is investing heavily in understanding SRM, but the potential downsides are enormous and dominate the debate. One of the biggest fears is messing with global weather. Models suggest SAI could drastically alter rainfall patterns, potentially causing droughts in vital monsoon regions in Asia and Africa or the Amazon, affecting food and water for billions. MCB could also shift rainfall, perhaps causing drying in other areas. SAI, especially using sulfate aerosols like volcanoes do, could damage the ozone layer, increasing harmful UV radiation at the surface. Researchers are looking at alternatives, but their effects are less understood. Remember, SRM doesn't stop carbon dioxide buildup, so ocean acidification, a major threat to marine life like corals and shellfish, would continue unchecked. Perhaps the most unique and terrifying risk is the termination shock. Because SRM only masks the warming, stopping it abruptly would cause temperatures to shoot up incredibly fast, potentially 5 to 10 times faster than the warming we're experiencing now. This rapid change could be catastrophic for ecosystems and human societies, potentially locking humanity into maintaining SRM for centuries, creating a planetary sword of Damocles for future generations. Add to this risks to ecosystems from changing sunlight, potential direct health impacts from aerosols, and the fact that cooling might not be uniform across the globe, potentially creating regional winners and losers. The list of potential dangers is long and deeply worrying. Beyond the environmental risks lie huge ethical and geopolitical challenges. The biggest ethical concern is moral hazard. Could the mere possibility of an SRM fix reduce the pressure to do the hard work of cutting emissions? Does it offer a dangerous excuse to delay climate action? Then there's justice. Who gets to control this global thermostat? Decisions made likely by wealthy nations could have devastating consequences for vulnerable populations, particularly in the global south, who contributed least to the problem but might suffer the worst side effects. How do we ensure fairness? And who governs this? There's currently no international treaty or body specifically for SRM. Principles like transparency and public participation exist, and the UK is building governance for its research, but deploying something with global consequences without robust international agreement seems fraught with peril, risking conflict or unilateral action. The UK's planned public dialogue in 2025 to 2026 is one step towards grappling with these societal issues domestically. This leads to a fiercely polarized debate. Should we even be researching SRM? Arguments for research often highlight knowledge is vital. We need to understand if SRM could work and, just as importantly, what the real risks are. Ignorance isn't bliss if the climate crisis deepens. Preparedness. If warming accelerates towards catastrophe, we need to know if there are any viable emergency options, however flawed. Research tells us what not to do as well as what might be possible. Informing governance science is needed to create sensible rules and policies, nationally and internationally. Filling gaps. Models aren't perfect. Some argue carefully controlled experiments like ARIA might fund are needed for real-world data. Arguments against research emphasize the risks are too high, potential for irreversible environmental damage, termination shock, it's just too dangerous, moral hazard, it's a dangerous distraction from cutting emissions. The only real solution, ungovernable, fair, safe global control, is likely impossible in our current world. Slippery slope research creates momentum and vested interests, making eventual risky deployment more likely. Opportunity cost: the millions spent on SRM could be spent on proven solutions like renewables or adaptation. Ethical objections, issues of hubris, intergenerational fairness and justice are profound. The UK isn't alone. The US, China, India, Australia and others are also researching SRM, mainly through modelling, though Australia has seen small MCB tests. International bodies like the IPCC and UN Environment Programme acknowledge SRM, but urge extreme caution, stressing the risks, governance gaps, and the absolute priority of cutting emissions. UNEP experts recently concluded large-scale SRM is currently not necessary, viable, prudent, or sufficiently safe. So the UK finds itself in a complex position, officially committed to net zero with no plans to deploy SRM, yet simultaneously becoming a world leader in funding research into it, including the riskier experimental side via ARIA. Is it a pragmatic hedge against global inaction, a necessary scientific inquiry, or a contradictory stance sending mixed signals? Solar radiation management is not a silver bullet for climate change. It's a bundle of highly speculative ideas packed with potential dangers and ethical dilemmas. The ongoing research in the UK and elsewhere aims to replace some speculation with data, but the fundamental questions remain. Could it ever be used safely? Should it ever be used at all? And crucially, will its pursuit distract us from the urgent task already at hand, cutting greenhouse gas emissions? This is a conversation we need to have, informed by science but guided by ethics and a global perspective. What do you think about SRM research? Let us know in the comments below. Thanks for watching.